Welcome to another episode of Moon-topia. I'm Irene Pease with the Amateur Astronomers Association in New York. So excited to be exploring some moons with y'all tonight. Tonight we're looking at Sheppard moons. So not moons that are orbiting around Saturn. A lot of folks might be familiar with Saturn's Sheppard moons. No, not those. And not the moons, the many moons that were discovered in part by Scott Sheppard. So we'll mention those just so we're all on the same page. But yeah, we're going to be looking at some Sheppard moons tonight. If you want to find out more about what the Amateur Astronomers Association is doing in your neighborhood, online, etc., check us out at aaa.org. You can follow us on social media at AAADOTORG. And for the visuals tonight, we'll be using OpenSpace, which you see in the background now. You can download that, use it for free at openspaceproject.com. And just a moment, I'm going to pop over to Stellarium to check out what's in the night sky. That you can find and download at stellarium.org. So without further ado, let's hop in to see what's happening in our night sky. What moons might be out there. So here we have our beautiful New Amsterdam sky. It's nice and light out. No comment. But we have our moon. We have our moon out tonight. Mars is still up there, nice and bright. We'll go ahead and fast forward to get a little bit darker. Uranus is over there. So we're going to be stopping by a few of these. We're going to skip by our moon, but I will mention, or just past new moon, and so I know a lot of people have been out doing Messier marathons. It's kind of that time of year. So if you missed this last weekend or the weekend before, there is another new moon, kind of still in Messier marathon season. So the April new moon is going to be early-ish. So if you don't get to do your Messier marathon hunting, whatnot, this month, you still have a chance to try and catch up in April. So for moons, other than ours, we are going to mention a Martian moon tonight, but we're not really going to be focusing on it. Mars doesn't have rings, and Sheppard moons are all about rings. But Uranus has rings, so we'll be seeing a few Uranian moons. And, well, all the giant planets have rings, but the others are up mostly in the morning. So if you're a morning person, the planets will be out kind of early. The ecliptic is still kind of low, so I would give it, I'm not getting up that early, I would give it another week or two to try to catch those. So they're a good distance above the horizon. So late March, early April, and then really you'll have the moon over there by Jupiter and Saturn. So we'll be looking at a couple of Jupiter's Sheppard moons tonight. And also Neptune. I think Neptune's basically on the other side of the sun, and we don't see it with the naked eye anyway. So we'll just kind of pass over Neptune. So moons and planets out in the morning right now, more so later in the month. Mars is still going to be up, and Uranus we're going to be losing to the sunset soon. So catch that while you can. The other thing that I should mention, there are actually... There's at least one asteroid that has a moon. Normally I don't talk about asteroids here, but I finally got to see my first asteroid. Super exciting the other night. If you're up for hunting an asteroid, Vesta is a really nice one to pick out. Pops right out in binoculars. It's basically the brightest thing between these two stars up in this region in Leo, and it's really booking it. Wow, it's already way over there. So it is going to be one of the brightest things in that part of the sky, but that's right, because I fast forwarded it a little bit. So as of right now, it's a little bit further back here between these two stars in Leo. We kind of rewind closer to where we are now, but it's still kind of the brightest thing in that part of the sky. So easy to pick out in binoculars. I expect to be able to see it from the city. I was just outside the city the other night. Really easy in binoculars, and then in a telescope it was almost harder because the field of view was smaller, but it's there. So if you've never seen an asteroid, it's a good shot. Vesta, go get her. And that's about it for the night sky. I want to pop on over to our moons in open space. And just to mention, if you have a favorite moon, any moon themes or anything that you're wanting to see and hear, please let me know. You can email me, irene.pease@aaa.org. Happy to take requests because there's so many marvelous moons. So what is a Sheppard moon? No, it's not John Sheppard from Stargate Atlantis. And it's not one of the many, many moons. So Scott Sheppard, I think I may have mentioned him. He's actually found several dozen. He's been part of groups that have found several dozen moons, over 60 around Jupiter, 45 accounted for Saturn, 2 around Uranus, 1 around Neptune. So that's a researcher. The name is spelled differently, but it still sounds like Sheppard. So he's at Carnegie Institute for Science. And so we have these scientists that are like looking for moons around our giant planets. But what I'm talking about with the Sheppard moons are moons that help shepherd the rings of these giant planets. So we have 4 giant planets in our solar system. We have the 2 gas giants, Jupiter and Saturn, and then we have the 2 ice giants, Uranus and Neptune. So we're going to go through all of the Sheppard moons except the Saturn's Sheppard moons. So most people are familiar, if they're familiar with Sheppard moons, you might be familiar with Saturn's Sheppard moons because Saturn has the most extensive and exquisite ring system in our solar system. So Saturn has 5 Sheppard moons. Some of them we've already touched on in other episodes of Moon-topia. So Pan, Daphnis, Atlas, Prometheus, and Pandora are the Sheppard moons of Saturn that are kind of shepherding the ring particles within the ring system. And I'm going to talk a little bit more about how that works and why that works with some of the Sheppard moons we will be talking about. So just the moons for Uranus, Neptune, and Jupiter tonight. And starting from the outside in, we're going to go to Neptune first. There's the Neptune. So Neptune, furthest out there, has only had 1 terrestrial visitor. That was Voyager 2 back in the late 80s. So it's been kind of lonely. But yeah, but it does have a very, very thin dark ring system. And it has 1 moon that we think is a Sheppard moon. So really what we know about Neptune, and to an extent Uranus as well, is very limited. And so some of this is kind of guesswork, really based on some telescopic observations and the 1 visitor, when Voyager 2 went zipping by. So you can see some of the orbits. I think you can make out some of the orbits of some of the moons around Neptune. The Sheppard moon is Galatia. Looks like Galatea. So Galatea is the 4th moon from Neptune. Let's see if we can focus on that one. So pop over to Galatea. So it's a little ways out there. Here we are. 1, 2, 3, 4. And again, these pretty much all of the moons that we're looking at tonight are kind of oblong. So you'll see this is a nice gray orb. We don't have beautiful maps of most of these moons because they're so tiny for the most part, or we just really haven't visited them much. There's kind of a view of Neptune from Galatea. It is tidally locked, and by tidally locked, we mean that the same side is always facing the planet. So like our moon is tidally locked. The same side of the moon always faces Earth, and we see this is true for most of the large moons in our solar system, as well as, whoops, that's a little bit fast, as well as some of these smaller moons. So just going to adjust our time here so we can run through time and kind of watch Galatea zip around here, just not that fast. Fast enough. Let's try that. So, yeah, so it's getting pretty close. It's getting even closer. It's slowly drifting closer and closer to Neptune. as it orbits around it. Our moon, in contrast, is moving further away from the Earth, little by little, slowly by slowly. And eventually it'll reach what we call the Roche Limit, which basically is when the gravitational pull of the larger body, in this case the planet Neptune, can basically pull apart and kind of strip the pieces of the smaller body, the orbiting thing, in this case Galatia. So that limit, that kind of closest safe point, depends a little bit on the masses of the objects and the density and composition. So this being so far out, we're not actually sure exactly where that limit is, but as far as we can tell, it is getting closer to Neptune, and it'll probably get stripped apart, meaning that its particles will probably end up becoming part of the moon. So, or part of the ring system. So when it gets kind of stripped off, all these little bits will be like kind of orbiting around Neptune and possibly become rings. So just to kind of give a little bit more perspective, we'll kind of zip out here. You can see there are some moons that are orbiting in a little bit closer to Neptune. But what does this one actually look like up close and personal like? Well, it looks like a smudge. So again, yeah, thanks to Voyager 2, we have this glorious image. So you can see it is oblong. So this is like, you know, what a higher def image is, I guess, that we have of this. But I believe I have an image of, the Adam ring, which is kind of the brightest ring that we know of Neptune. And it has these arcs in it, which are not well understood, right? So there's these brighter bits of the ring itself, which is kind of interesting. And it's orbiting right around in the same distance the Galatia is from Neptune, which is why we think that Galatia is one of the Sheppard moons. Again, it's not like for sure, because again, there's just a lot that we don't know because of our limited experience with Neptune. But the arcs are kind of a mystery. The arcs in the Adam ring are a bit of a mystery because we can't really account for them based on resonances with Galatia or the other moons. So it's kind of like, why do we have this feature? Why is that even happening? Don't know. So a good reason to send something out to Neptune in the future. All you Neptune fans, start petitioning NASA for another mission to Neptune to figure that one out. So probably a Sheppard moon, and there might be another one helping to shepherd that Adam ring that we just don't know about. But again, there's a lot we don't know about Neptune. So that's Neptune. So we can go ahead and take a jump, whoosh, swirl into our next ice giant, everyone's favorite planet to make fun of, Uranus. There it is, whirling and twirling around like you do. And I keep getting confused. Which way is that? South? North? All right, okay. I like to look at the planets with a certain orientation. I'm used to saying, all right, so this is looking, that's south. Okay, whatever. So we'll orient Uranus thusly. So it's winter or summer, winter and summer. Looks like when you have one of the poles kind of facing the sun at the moment. So Uranus has the most extensive and glorious ring system after Saturn. So most people are like, yeah, Saturn, rings, great. And then like Uranus is like, hey, I have rings too. Yes. And I'm just seeing in the chat that, Uranus's moons are named after characters in William Shakespeare and an Alexander Pope poem as well. So we did, if you go back, there's a Moon-topia episode, Act 2, about some of the Shakespearean named moons. So yeah, that's a great fun fact. So we're going to be focusing on two Shakespearean moons, Cordelia and Ophelia. And again, I'm not an expert on Shakespeare, so don't even ask me because I won't know. But these are both orbiting, kind of shepherding the brightest ring of Uranus, which we're not seeing. We don't see the rings here. That'll be an ask to get some rings in open space. I have no idea what's involved with that. But one is kind of on the outside of the epsilon ring and the other's on the inside of the epsilon ring. So let's go ahead and focus in on, I think I have Ophelia here first. Nope, just kidding, Cordelia. All right. So I think this is like a kind of one of the outer rings. So the rings are a little closer in. If we come in here, this is our Cordelia. Great. Thanks, Cordelia. And kind of poke around, watch Cordelia as it orbits around Neptune. Great clouds. Way to be cloudy, Neptune. So we go ahead and play time a little bit. We can see it tracking along. Very nice. So Cordelia is the innermost of Uranus's moons. It was also discovered by Voyager 2. And it's also slowly decaying, and it's also tidally locked. So we're seeing some themes here. So these slowly decaying, very close inner moons that are tidally locked and probably going to get stripped apart at some point. It's also oblong. So it has dimensions. It's a little bit, about 50 by 36 by 36 kilometers. So kind of a oblong thing there. But it's just on the inside of the epsilon ring. And then its buddy Ophelia is the next moon out from Uranus, and that's just on the outside of the epsilon ring. So how does this whole shepherding thing work? So in some cases, in this case, and then in the case that we'll see on Jupiter, you have kind of a tag team. So we can imagine if you have a ring particle and it's coming along and it's on the inside, but it's being pulled towards the moon, then the moon's gravity is going to give it kind of a kick, so it'll speed up and then it'll end up in give it more energy, I should say. So it ends up in a higher orbit, so not necessarily faster. So the things that are closest actually are the fastest, but kicking it up to more energy, so it has a higher or more distant orbital radius, as opposed to something that could be coming from the outside, coming in towards the planet, and then it'll get some of its energy maybe absorbed by the planet and down to a lower orbit. So what these Shepherd moons do is they might kind of clear a path through a ring system. So that's kind of what we see in Saturn's rings, like most of the gaps in the rings, the divisions between rings have moons that have kind of cleared those out. So they're kicking particles to either side, either in or out, and kind of keeping that throughway kind of empty. So that's a little bit of what these Shepherd moons are doing here. But now we have these two moons on either side of the ring. So again, Cordelia kind of on the inner side of the epsilon ring, and then Ophelia would be that next one out, more towards the outside of the epsilon ring. Ophelia is just a little bit larger, and basically we don't know anything else about it. We have approximate dimensions, but again, we just have like these Voyager 2 images, and just to show you how glorious those are. Yep, that's Cordelia and Ophelia. So just these kind of oblong smudges, not a whole lot of info. But as I was mentioning that, the inner things are going to move faster. So we're seeing the inner Cordelia slowly overtaking Ophelia. So the inner moons are always going to move faster. That's one of Kepler's laws of planetary motion. Basically, it works for moons as well, that it ends up being that things that are closer to the main body are going to orbit faster. They're going to be moving faster, and they also have a smaller distance, so they'll be going around it faster than things outside. So the innermost moons are always going to be the fastest moons, and then they'll be slower further out. So we have Cordelia and Ophelia shepherding the epsilon ring of Uranus. Very lovely. Lovely pair there. Yeah. So then I guess we can move on. Our last but not least stop is going to be much further in, much closer to home. We can find it back towards the sun somewhere. We have a Jupiter. Yeah, all those other planets in there. The ice giants are really far out. Like, I understand why we haven't sent anything else out there. Holman transfer. Faisal's asking, so Sheppard moons do a Holman transfer? No idea. You tell me. I'm not sure what that is. But yeah, good question. So we're going to pop back in to the Jupiter. And people are probably familiar with at least, maybe the four largest Jovian moons. If we come up here, there's the lovely, lovely Jupiter and its lovely Jovian moons, as well as a few inner moons. So what's turned on now, I think we see, so we have the four, I think these four, 1, 2, 3, 4, they're kind of faint. And I think in here, maybe even this one, I'm too far in. But we're going to be looking in really close at a group that's called the inner moons. So I was last month or the month before, we looked at the Himalaya group. But this month, we're looking at 2 of the inner moons, the inner moon group. But first, we're going to make a pit stop at Io. Why Io? Oh, I'm so glad you asked. Because it's lovely. All right. So Io is the innermost of the Galilean moons. So the 4 large moons that Galileo and others, you too can see this in a night sky near you. With binoculars even, they pop right out. So I don't actually want to see this side of Io. I want to see Io's view of Jupiter, which is dark right now. Great, okay. So we'll turn on some time, and I'll try not to lose Io. Let me adjust our speed. Yeah, no, that's probably fine. Right, so Io moves around Jupiter every 4 days-ish. And so we'll just kind of see how that looks. So you'll see the inner moons passing it, lapping it on the inside. And you can see Jupiter spinning in the distance. So you can see it spinning. So if you curl your fingers in the direction that it spins, you curl your right hand in the direction that a planet is spinning, then your thumb points in the direction of its north pole. So that's the right-hand rule for planets. So we see Jupiter spinning to the right. Right, because that's the way it spins. That's the view from Io. Oh, look, there's a big red spot. And we have a response about the Holman transfer. So I hope we'll have a good explanation of the Holman transfer in the comments or a nice link to it. Otherwise, I might have to follow up. All right, so you've got this view from Io. Everyone locked in on that? Great. So now we're going to pop over to these inner moons. So the innermost moon, we have Metis and we have Adrastea. So we'll visit, I have Adrastea on my list first. We bounce over to Adrastea. And whoop, it's on the other side of Jupiter. So instead of going crashing through Jupiter, do this the safe way where we don't accidentally crash through the gas giant. Avoid crashing through the gas giant when you can. Okay, so Adrastea, again, we don't have a picture. I didn't even bother like putting a picture in here because again, it's just a little blob. But also oblong, also believe tidally locked, and also, very close. But now, Adrastea is this one? Yeah, this is the one. Quite close. It's so close, it has not just a synchronous orbit, it's actually inside of where the synchronous orbit would be. So if we're at Adrasia, and we're looking at Jupiter. Notice which way Jupiter appears to be rotating. It's to the left, folks. To the left, right? So it was to the right, right? Because that's the direction that it's rotating. Yeah, but from Adrasia, it's to the left because here, again, we are inside of the synchronous orbit, which means that this moon is going around faster than Jupiter rotates. So, yeah, so it's like lapping Jupiter, so to speak. So that's pretty nifty. That's something different. So both Adrasia and its little partner Metis are doing that. So they're inside of the synchronous orbit. And again, probably going to get torn apart at some point when they get a little too close. So these are very tightly, as a pair, they are very tightly shepherding the main ring of Jupiter. And they're probably also both providing material for the main ring. We have images of these from both Galileo, not the astronomer, but the Galileo probe that went and visited Jupiter back in like 2000, and also some images from New Horizons that went sweeping past in 2007. So I think these are kind of hard to see, so I made a thing. All right, so here you have, remember this down here was Adrasia, and then this up here is Metis. And you can see their orbits are very, very similar. Metis is just a little bit closer in than Adrasia. And it looks like they're basically on opposite sides of Jupiter. And at the moment they are. This is actually like real time. But if we go ahead and run time like, fast, ignore the diameter kind of line. Over time, they do sync up, right? So it's just kind of it just so happens that right now they're basically opposite each other, more or less, from Jupiter. But again, Metis is just a little bit closer to Jupiter, so it's just inside of Jupiter's main ring. So it's going to go a little bit faster, so it's going to be catching up and eventually lapping Adrasia that's just a little bit further out. Metis, being the closest, is the fastest, and in fact, it's the fastest of the moons in our solar system, moving along at 31.5 kilometers per second, which is like faster than the escape speed from Earth's surface. So it's really booking it. And as you can see, it's just a little less than a Jupiter radius away from Jupiter. So it's less than 2 Jupiter radii for its orbital radius. So there's one Jupiter radius, and then this is another like 0.7 Jupiter radius. So it's really close in there. And Adrasia is the smallest of the inner moons. Metis is a little bit bigger. Adrasia is like 20 by 16 by 14, and Metis is like 60 by 40 by 34. It's the second smallest. So small little moons, but kind of interesting. Just in the way that they're working together to kind of shepherd, keep these particles in this one region at a certain distance from Jupiter. And one other kind of interesting tidbit about Metis is that, being oblong, it's and zipping around as fast as it is, it has a slightly reddish hue. And we think that, and also it seems to have a little bit lighter color on one side than the other. So we've seen another moon like this. So that's not Metis, but that's Iapetus, one of Saturn's moons that has like that kind of light and dark for a very different reason. So again, this was probably some other activity that was blowing stuff off, and then it was like frosting onto the other side. But think like Iapetus, but totally different cause. So we think that the leading side of Metis, as it's zipping around at, 30 some odd kilometers per second, that the leading side has more collisions happening. So that's like kind of chunking it out and exposing probably ices on its surface and making that side lighter and brighter. So more reflective than the lagging side. So kind of interesting, fun little flavors of different Sheppard moons. So that's our tour for this week. So we had a Sheppard moon of Neptune shepherding the Atom ring. We had some Sheppard moons of Uranus shepherding its Epsilon ring, and these last two Sheppard moons of Jupiter shepherding and keeping that main ring in check. So, and I see there's a lot of exciting discussion. I'm glad I dropped the Roche limit. It looks like someone's explaining the Roche limit. Thank you, Jim, for that. Fantastic. And thanks everyone for tuning in for another episode of Moon-topia. Hope you've enjoyed it. And again, if you have requests or suggestions for moons to visit or focus on, please let me know. You can put it in the comments or send an email, irene.pease at aaa.org. So again, I'm Irene with the Amateur Astronomers Association out of New York City. Find out what else is happening with AAA. We have lectures, we have classes, we have meetups, and we will have some observing at some point for our members and at some point for the public as well. So that's all at aaa.org. Follow us on the social media things at AAADOTORG. And just again, mentioning the visuals, you can find and download them both for free. OpenSpace, which you see in the background now, is at openspaceproject.com, and Stellarium, which we saw earlier, at stellarium.org. Thanks so much for tuning in. Clear skies, everyone. Be safe out there.